When you take a dip in the ocean, the pH of the water probably isn't on your mind. But what if I told you the ocean's acidity is actually rising?
Let's talk about ocean acidification, a phenomenon involving the decreasing pH of Earth's oceans.
In order to explain ocean acidification, it's first necessary to explain what pH is. In simple terms, pH is the measure of how basic or acidic a solution is.
Acidic solutions have an excess amount of hydrogen ions, while basic solutions have more hydroxide ions. pH stands for power of hydrogen. The equation for pH states that pH is equal to the negative of the base 10 logarithm of hydrogen ions. While this equation may seem confusing, it really just represents the concentration of hydrogen in a solution on a logarithmic scale. Logarithmic scales are helpful in showing a wide range of values. pH is represented on a scale of 0 to 14, where anything above 7 is basic and anything below 7 is acidic. A pH of 7 is considered to be neutral. The ocean currently has a pH of 8.1, a decrease from the 8.2 pH prior to the Industrial Revolution.
So, why is our ocean's pH changing?
The burning of fossil fuels releases carbon dioxide, CO2, into the atmosphere. One third of atmospheric CO2 is then absorbed into the oceans. The absorption of CO2 into the ocean can be helpful to the environment because it decreases the buildup of greenhouse gases in the atmosphere, but unfortunately, CO2 then ends up causing problems in our oceans. Once dissolved into the ocean, CO2 reacts with water molecules to form carbonic acid. This carbonic acid then further breaks down into bicarbonate and carbonate ions. These new forms of carbon contain more hydrogen ions, which increases the ocean's acidity.
Ocean acidity has increased about 25% from pre industrial times to the 21st century, a pace faster than any other time in Earth's geologic past.
The impact of ocean acidification starts with calcifier populations. Calcifiers are organisms that rely on calcium carbonate to synthesize shells and other skeletal structures. Calcifiers include clams, oysters, crabs, urchins, and even some types of shelled plankton. Because calcifiers are reliant on calcium carbonate in order to survive, any changes in carbonate chemistry in ocean waters can greatly impact their population levels. The combination of higher water acidity and low levels of calcium carbonate weaken the shells of calcifiers. If calcifiers can't build their shells, or if their shells are weakened, they are unable to defend themselves against predators or other environmental conditions and are more likely to die out.
Calcifiers are near the bottom of the food chain, so when calcifier populations go down, the rest of the marine ecosystem is impacted. This leads to problems for humans, too, because many humans rely on the ocean for subsistence.
Overall, it's clear that ocean acidification is a threat to waters across the world. Luckily, with more awareness of the issue, more and more climate scientists, engineers, and others will be able to work on finding a solution using chemistry and other types of science and technology.